So let's continue from the same point where exactly we left off. And over here we have the Emit command. This is basically the syntax of the Emit command. Now we just need to close the brackets, and here we go. Hit the option edit and no more errors. Very nice. But there is one important thing which is required to be fixed. Well, we created an object that is point. Over here if we go, notice we have the object name point, but we don't have in the outliner. So the emit command will not execute this until unless we have a particle with the name point. So that's fairly a simple thing to create. We can simply go over here and let's say we have the nParticle name point execute. Alright, so here we have nParticle point. Now let's change the color to the green for better visualizations, and change it to the sphere. I'll also change the radius to, let's say, 0.1. Now let's play the timeline and notice the beautiful change. And here we go. So notice carefully, the red particles are still colliding with the smaller passive collider, but still they are not emitting the green particles, because we have given the condition that if the collision geometry index equals to 0, and as a result of this, now these secondary particles are emitting just after the collisions, which is really very nice. All right, we can also do one more thing, like we can change the preference of collision layer from the 0 to the 1. So by making this, now we are giving the priorities to the red particles. All right, and this is something very, very nice. And we can also simply increase the let me just also reposition this. We can just simply increase the number of particle emissions. So what if we just want to increase the birth of the particle? Let's say instead of 2, let's say we have 9. So the particle ranges between, let's say, 3 to the 9. All right, hit the edit, and I think so everything is good, not a problem. We can also increase the values of the random, you can say, the velocity, so that we can have some more better control, and that's nice. Now let's play the timeline and notice some changes, and here we have some more particles. So it's really not a problem. The more you want, you can have just by using the int $birth value. You can just add as many particles as you want, and that's something very, very nice. Now the next question is, what if I just want the red particle should die the moment they collide with the passive collider, but the green particle should also emit? Well, it's fairly a simple thing. We can just put the lifespan pp in this. So first we are required to change the lifespan mode from live forever to the live lifespan pp only. Go inside the expression editors and just add only one line, which is the nParticle shape 1 dot lifespan pp equals -1. So with this, it solves your problems. Now if you want the red particle die just at the moment of collision, well, that's also possible. All right, but this is something which is really very nice. All right, but now let's do one thing. What if we just want the red particle to be remain there, the green particle should also emit after the collisions, but the emission of the green particle should happen only for once? Well, this is something a little tricky. All right, now let's say if I just rotate this sphere, and I just don't want particles to slip from this, you can notice that, okay, first I need to remove the lifespan pp to address my question. Once the red particle collides with the passive collider, the ID changes to the 0. So as long as the ID remains 0, the green particle emission will be continuous, and that is the case I don't want. I just want the emission only for once. And notice the particles are consistently getting emitted, and this is also something very nice effect. You just keep visualizing in which way you want this effect to this is something really, very nice. So let's do one thing. That's the reason we have learned the limited thing, which is particle collision event editor, but this time it will really benefit a lot. So let's do one thing. Let's go inside the particle collision event editor with the nParticle 1 selected. Let's say we don't want any further emission of the particles. We just want to create an event. Let's say we hit the option create event. Now event 0 is created, but we don't want the emission of the particles. Let's close this. Now let's do one thing. Let's go inside the expression editors and give another condition, that is if nParticle shape 1 dot collision geometry index equals to 0 and we have nParticle shape 1 dot event also equals to, let's say, 1, then in that case only the emission should take place. Now you remember, the particle, if it keeps hitting the passive collider, the events keep on increasing, but here we are giving the condition for 1 only. So if nParticle shape 1 dot event equals to the 1, only then the emit command should execute itself. So we have two conditions. We have the collision geometry index is also equals to 0 and this. Alright, so let's hit the edit and let's see now what we have. So now if we play the timeline, we'll notice, and there we go, something really very nice. So it simply means that everything is in our control, and this is the best thing which I like inside the expressions. I tell you guys, it's little difficult to grab things like MEL scripting or Python scripting. The advantages, it's is absolutely amazing. I mean, we just simply cannot control all such behavior that we just saw with the help of these expressions while using the normal or the limited attributes which Maya has offered to us in its UI. So if we have the skill and ability to create the expressions, I think we don't have any limitations inside the Maya dynamics, which is classic but powerful. Alright, so I hope so you must have understood the concept. Now let's move to the next clip where we talk about the particle self collisions and particle collision component. Alright, so let's get started.